the pleasure to introduce you to Professor Gavino Puglioni. He's the Statistics Section Head and Director of Graduate Studies at the University of Rhode Island Department of Computer Science and Statistics. Born in Nuoro and raised in Orune, a small town in central Sardinia in Italy, got his Bachelor of Science in Economics, focused in econometrics, from Bocconi University, Milan, with honors, of course, and earned his Master of Science in Economics at the same university. He has been working in different researches at Duke and University of North Carolina. His main areas of research are related to the development of applications of Bayesian methods, being particularly interested in the analysis of dependent data, stochastic differential equations, mixtures, and model averaging. He also collaborates with tons of different scientists and different areas like ecology and environmental science, biology, oceanography, pharmacy, epidemiology, economics, among others. And currently, he serves as a postdoctoral researcher working on different projects that includes point processes to study sea turtles' nesting sites and ecological models for the spread of raccoon rabies. So, as you can see, we have a very knowledgeable person here. Professor, thank you very much for being with us tonight.
Thank you so much, Monica, for the introduction. Buenas tardes y estimadas y estimados estudiantes, bienvenidas y bienvenidos a esta nueva edición de Ciencia de Datos por Todos. Disculpe mi español, es no muy bueno, pero yo soy muy emocionado de estar con todos vos. This is a really big honor and privilege to hold the inaugural lecture for this edition of this program that, from what I was told, is the largest in the history of Correlation 1. Over 1,800 students are currently enrolled in this program. And for me, it's really special because of my love and appreciation for Colombia. It's a country that I visited a few years ago. It was my highlight of my sabbatical year. And I really enjoyed very much visiting your country. And I'm planning to actually come back in a few months to visit some colleagues at Universidad Los Andes in Bogota. And I would like to tell you something more about me that goes beyond the academic aspects that Monica was discussing. And as Monica mentioned, I was born and raised in Italy, which is my country that I love and miss a lot all the time. And Italy gave me the love for good food, good music, good company, all things that actually I find anytime that I come to Colombia. And so I really hope that over time we get to know each other better. We'll spend several evenings together learning about data science. And hopefully we can talk together about our interests. I love sports, I love music, I love cooking, I love traveling, and I hope to hear more about you as we go along. The goal of this class is actually to establish some of the basic terminology that relates to data science. We are not going to go through a lot of technical details this evening. We are going to have a gentle start, a gentle conversation about some of the most important topics and ideas. And I invite you to send me feedback, ask questions on the Slack chat. I probably won't be able to read them all because it's many of you, but I'm already seeing that there are a lot of reactions already. and thank you for the warm welcome. Danielle is actually pointing out that the fact that both Colombia and Italy will not be going to the World Cup. That's kind of a sad moment that came earlier this week, but hopefully we will have other chances in the future to do well in football. And thank you all for your warm welcome. So let me start sharing my screen. Well, I would like to show you today's introductory case. I hope you can see it. So we're going to introduce some of the most common words. These are buzzwords that you hear all the time when you hear about data science, and people use them sometimes not exactly in an appropriate way. So the goal of this class is that actually you will become more knowledgeable than many journalists and many people that use these words interchangeably when they really mean different things. In particular, we are talking about data science, machine learning, and artificial intelligence. All of these words, expressions have some relation with each other, but they mean different things. So let's start with some basic definition. Data science is formed by two words, data and science. Data, it's a word that actually comes from Latin that means datum. Datum means something that is given. And it's given in the form of information. And so any type of information is considered data. One of the things that we say here in the US is that knowledge is power and information is power. And what is information? Information is piece of knowledge, is something that we care about, and something that helps us understand in the world, something that gives us knowledge. We all carry a lot of information, personal information, knowledge about the world as we experience it. But there are types of information that are actually valuable, that are valuable to companies, that are valuable, that have a market value. And even things like your name, your address, your telephone number. Did you notice how sometimes you go to a grocery store, to a supermarket, and you are given a card with discounts as long as you provide your address, so they can send you advertisements. You provide your phone number, they send you reminders. Oh, you need to buy this, you need to buy that. So all these pieces of information is data. And data science, the other part of the word is science. Science means that we are trying to use the scientific method to analyze and interpret data, interpret information, extract information from large amount of data. You might have heard that data are treated through the use of algorithms. What is an algorithm? An algorithm is like a recipe. When you are preparing a cake, you follow a set of directions that you have to do in sequence in order to have a good cake. You want to do them, to follow this direction in an accurate way so that the cake turns out to be good. Or sometimes you have an algorithm that implicitly you implement to make something function. Each time that you start the car and you start driving, there is a list of commands that your brain tells your body to execute. Algorithms are a very, very important part of data science, machine learning, and artificial intelligence. And throughout this course, we will learn about different algorithms and how they are used and what they are used for. Some of the algorithms might be more or less successful in providing the answers that you want. Think, for instance, about the closed captions that computers in real time have to provide when they are trying to interpret speech. They can be more or less accurate, more or less precise. Or think, for instance, about the weather forecast. The weather forecast are the result of models, algorithms that try to predict what the weather is going to be. And with measurement and prediction comes the question of how good the prediction. And you often hear words accuracy and precision. And many times you hear them used interchangeably when they really mean something different. So defining exactly what accuracy and precision is going to be very important for us in order to be able to understand and compare the performance of different algorithms and of different models. So the accuracy is defined as the degree of closeness of measurements of a quantity to that quantity true value. So something that is accurate, it means that how closely you get to the truth. So if I check my phone to check tomorrow's temperature, and I see that the high temperature at noon is going to be 20 degrees Celsius. Then tomorrow I see, oh, they're 21. I say, well, it's close enough, or it's 19, it's close enough to 20. So in that sense, I can say that the algorithm was accurate in predicting the temperature for tomorrow. What about precision? Isn't precision the same thing? Well, precision is a little different. Actually, depending on the point of view, it can be considered very different because it's the degree to which repeated measurements under unchanged conditions show the same results. That is, if I try multiple times to repeat the process under the same conditions, do I get a similar result? Doesn't have to be necessarily close to the true one. There has to be, but it has to be similar to the previous value that was predicted. This graph illustrates very well the difference between precision and accuracy. So here you have a target that ideally you would like to reach the center consistently. Here you have a shooting system that is very precise, because notice that all the axes that indicate where the shot was delivered are all close to each other. So we see that the shooting system was very precise, but was not accurate because it's missing the center. On the second target, instead, we see that all the shots were somewhat close to the center. So we have high accuracy, but low precision. Why low precision? Because all the shots were far away from each other. However, they were on the ballpark. They were close enough. Now, if you had both precision and accuracy, you would see that all the shots would land exactly in the target. And here you have an example. The third panel is actually a target where the shooting system was neither precise nor accurate. Notice that, all the shots are somewhat off. So if you were participating to the Olympics and you were doing archery, you would see that, well, this is probably not a good performance, okay? So keep in mind this definition. The reason why we're giving these definitions is because they will reappear when we talk about estimation, when we talk about performance of algorithms and so on. So what is data science? We touched upon this. And I mentioned how science relates to the use of the scientific method. what is the scientific method? The scientific method, which actually originally was developed by Galileo Galilei, famous Italian scientist, and who, not just he correctly stated that the Earth rotated around the sun, but the most long-lasting consequences have been in the development of the scientific method. And the scientific method is based on or an algorithm, if you want to, which is, at the first step, you formulate hypotheses or guesses about the laws of the world, how the world works, based on observation. So the scientific method is based on observation. And if you see apples that are falling from trees, you suspect that there is a force that is attracting the apples from their position to the ground. Observation leads to guesses, okay? Now, the first guess then needs to be validated or denied, depending on the result, conducting experiments. So the scientific method is based on these two steps: observation, formulation of hypotheses, and then validating or denying the hypothesis by conducting experiments. So an experiment has to lead to conclusions that can be falsifiable, in the sense that you need to be able to provide experiments that can give you both outcomes or many different outcomes. So outcomes that can either corroborate your hypothesis or negate the hypothesis. So this, and data is information, and data is knowledge or pieces of knowledge. We can say that data science is a discipline that uses scientific methods, but is also interdisciplinary. Why is that? Well, we said that data and information are everywhere. So we need to be able to learn methods that can be applied to a variety of disciplines. And using the scientific methods that involves processes and algorithms, we can get knowledge and insight from different sources of data. It can be structured or unstructured. So data science is related to data mining, machine learning, and big data. And we'll see what these concepts are. However, they are not, machine learning, data mining, big data, artificial intelligence cannot define by themselves what data science is. So data science can be stated as the discipline that uses scientific method to interpret and extract knowledge from data. So, based on what we have learned so far in terms of what data science is, what among the following statements can be classified as a data science process? So the exercise asks you, is a simple exercise, but it asks you to try to reflect on which ones can be considered data science. So let's start with the first. You have a meeting with your boss, and you present her with some data using Excel charts with any insight about the data. Say, okay, here's a bunch of numbers, and this is what I have for you. Is this data science? We might want to think about it. Observing that Uber pricing seems to be correlated to a small set of factors, obtaining open source data on Uber pricing rates, then building a pricing model based on those factors and verifying that they explain most of the variation in rates. What these factors can be? Well, perhaps you notice that in certain times of the day or of the night, Uber rides might be more or less expensive. Or areas of high traffic and areas of low traffic might have different rates. And then you might say, wait a second, if I use this information, I can probably predict how much the ride will be. Also, it will depend perhaps on how long the distance of your ride needs to be. So is this a data science problem? Think about it. You're noticing something, and then you're using possible sources of data to explain why you're observing that. Then you have C, converting images of crop circles into structured pixels and storing them into a database for later use. Well, so you're just storing some pieces of image for later use without further context. Then you have D, building an algorithm that allows a computer to recognize images of cats and dogs. And then you have E, using people's profiling data to build a model capable of predicting your compatibility percentage to find a person's perfect match and soulmate. So, some of you are commenting on the chat, which one do you think that can be data science processes? I'm hearing some votes for B and E. C is an electric and ETL process, E and B, B and E. Okay, a lot of evidence for B and E. Nice. And the answer is B and E. Correct. So, why B and E are correct? Both of these scenarios involve the two steps that we discussed for data analysis and for data science, pardon. The hypothesis, experiment, process. For instance, why the other ones are not data science problems? Well, A doesn't have any analysis. You're just presenting some Excel data tables. You're not providing prediction. You're not providing interpretation. All you're doing is just providing raw information that was not processed. And why C? Well, C is a data engineering problem, which is not reflective of the entire data science process. Remember, C was converting image of crop circles into structured pixels and storing them into a database for later use. This is about storing data, and is not really trying to test any hypothesis or providing any new insight. Not just yet. Maybe one day that data can be used in a specific context, and then it can become a data science problem. D is also not a data science process. Why? D is probably the closest to a data science process without being, because it says building an algorithm that allows the computer to recognize images of cats and dogs. We are not doing hypothesis testing here. We are just building an algorithm that is predictive, a model that is not meant to really test any hypothesis about how the world works. Okay? So we have defined and we have learned what data science is. Let's say something about what data science is not. So data science is not computers recognizing images of cats and dogs. That's not data science. Data science is not IBM Watson screening human tissues for disease. Data science is not AlphaGo beating the world's top Go player, or Deep Blue defeating all the top chess players in the world. That's not really a data science problem. It's a computer science type of problem. It can be seen as a machine learning type of problem, but it's not necessarily a data science problem. I would like to point out that all of these systems use data in a particular way. So they are still data applications, not data science. So the vast majority of data use are not like the ones that we have talked before. In traditional sciences, we always have acquired data to test hypotheses. When we take to test the physics law, or when we make an experiment to determine whether or not a new medication is effective. That's a data science problem. So most examples of data science are what we described in part B and E. A common corporate data science example. So let's try to put the concepts of data science in a more business scenario. Imagine that you are a firm that sells a particular type of products, and whether that product is something tangible or is a service, and you want to use the data to categorize the customers, trying to understand the customer behavior, so that you can propose some marketing campaigns that can be persuasive to target specific segments of your clientele. Imagine that you are a firm that produces clothes, and you notice that most of your customers are I don't know, athletes on their 20s, and then there is another group that is a little bit older, in the 50s, people that perhaps they're close to retirement and they start exercising and they need to purchase a lot of athletic gear. Then perhaps if you want to come up with marketing campaign, you want to have one that appeals to the younger people on their 20s, and then something also for the older crowd. And you want to use different language, different music, different system. Luis is asking a very interesting question. What's the difference between data science and inferential statistics? And it's an excellent question, because statistics is the heart and soul of data science. There are some data science methods that use different systems to test hypotheses that are not necessarily statistical, okay? And in that sense, we can say that data science can be potentially a little wider. There is one part also of data science, of theoretical data science, that really deals with the formulation of algorithms, and the application then they are going to be data science problems. But indeed, statistical inference is a big, big part of what data science is. So Luis Miguel, thank you very much for your excellent question. Some of my statistics colleagues go as far as saying that statistics is the entire data science. I prefer saying there is a very large portion of data science. Some of the examples that we mentioned before, like computers recognizing cats and dogs, or systems used to analyze cell images to detect diseases and so on, sound a lot like artificial intelligence, because you are using an artificial system, a computer in this way, to come up with intelligent statements and conclusions. And the methods that are used in this type of applications, they are typically called machine learning. And we are going to define now what machine learning is. Machine learning and artificial intelligence are also different, and we are going to define what the difference is. Machine learning defined in the 90s by Arthur Samuel, who described it as the field of study that gives the ability to the computer for self-learn without being explicitly programmed. So in other words, the goal was to create a machine that can learn from what? From data, from information, and then being able to keep learning without receiving instruction on what the machine learned. So a machine that does not require hard coding and that just by processing the data that is acquired can provide predictions and output models. Somebody in the chat posted an excellent plot that I actually use also in some of my classes about what data science is. Data science in this plot, I invite everybody to check on Slack because it's a very enlightening plot. And this is why I'm always a little bit more conservative in defining data science as entirely statistics. Now, don't be fooled by the size of those of that Venn diagram. I do believe that statistics takes a much large portion of data science. But notice that says that data science is at the intersection of computer science, because we say it's necessary to program machines that allow us to process large amount of data, mathematical and statistical methods that provide the actual theoretical knowledge that can allow us to program these machines in a way that makes sense numerically, and then domain and business knowledge. While this is referring to the scientific knowledge that is necessary to interpret the data in a veritable way. After all, you can apply a statistical process to the data and test the hypothesis. However, the hypothesis has to have some kind of foundation on previously produced science, and the interpretation and the consequences of a particular finding need to be interpreted using science. So data science as a discipline does receive inputs from these different branches. However, the process that is used is very, very close to what a statistical inference process looks like. So obtaining information, establishing a guess or a hypothesis, testing the hypothesis. Now, statistics tells you what is the appropriate way of testing the hypothesis, but the hypothesis has to be the scientific knowledge. And many times, the statistician comes into play once the hypothesis has already been defined. And this is why we cannot quite say that statistics and data science are exactly the same thing, okay? So thank you to Sebastian, I don't know how you pronounce your name, and for the useful graph. Joseph sharing another, it's a meme actually. No one is made to be rejected. And somebody said, oh, the null hypothesis. That's a joke for statisticians. I love it. Thank you. So let's go back to machine learning. So we're trying to build this machine that without being hard-coded is able to process data and produce output. So where do we use machine learning? Does it have areas of application? Well, actually more than you might think. It can be is used widely to some of the smallest tasks, to very, very intelligent insights. Some of the home device systems like Google Home, Alexa, or Siri, they are based on machine learning. So they are able to interpret your commands, your requests, based on long sequences of data training that they have been able to generalize and to apply to a specific case. Um, and there are many areas of application for machine learning. Uh, Machine learning methods are used also, like, all the systems that are used in modern contemporary cars that have self-driving features, or that they have systems that recognize danger. For instance, if you get too close to a car and your car immediately stops or slows down, or if your car is going outside of the lane and then applies a correction to your steering wheel, all of those systems are based on machine learning methods. So let's see some of the uses for machine learning. So prediction. To predict, for example, demand, prices, and so on. This is similar to what econometrics does or time series analysis does. Image recognition. Our cell phones these days unlock when we look at the screen, even if we look a little bit different from the moment that we took the original picture, because perhaps, I don't know, our hair is longer, we have a beard and so on. But the algorithm is good enough that says, okay, well, that's a good representation of the fingerprints recognition that you have on your phone, you have on your computers, and so on. So image detection, very typical type of application for machine learning. Medical diagnosis. This has been a very important contribution of machine learning. Samples of tissues used to be interpreted directly by the physician, and that would go with a microscope and check if the cells looked cancerous or not. The input of the doctor is still very important, but machines, computers, are much more accurate in recognizing anomalies in tissues that are harder to see by the human eye. So machine learning can be used in finance and trading, for instance, to identify fraud investigations and credit checks. Ride-sharing apps, we mentioned before, the use of different factors to predict a good price for an Uber ride. And we'll talk more about machine learning in further classes with me and other instructors as well. And we'll talk about the difference between different areas of machine learning. We have supervised learning and reinforcement methods. And we'll see what they mean. They all have in common the idea that a machine is trained to process information and produce output that is in a different setting than what it was before. So we talked about data science, we talked about machine learning. Let's try to define what among the following scenarios, which ones follow under the umbrella of machine learning. So we have A, building the model backing Apple iPhone's facial recognition system. Constructing the model backing Netflix's movie recommendation system based on your previous viewing activity. Investigating factors which affect Airbnb pricing and developing a pricing tool based on this analysis. Setting up an automated system to approve or reject mortgage loans applications. Your bank, before giving you a loan, wants to know about your consumer behavior, if you are able to save, if you are on time with your payments, and so on. So which ones of these sound like machine learning application? And I'm seeing that some people are saying A, B, C, D, all of them. Wow, you are all fantastic. And the correct answer is all of the above. Great. So A, we said building the model backing Apple's iPhone's facial recognition system. Notice that we are talking about building the model. So that means programming the machine. So A is similar to the task of recognizing cats and dogs in images, which we have discussed in a machine learning problem. B involves building a computer model that can learn your movie preferences based on your previous activity. I have to say Netflix is actually pretty good at providing good recommendations. Mitigating factors which affect Airbnb pricing and developing a pricing tool based on this analysis. If you have a room that you're renting and you want to come up with a good price, what is a good price? A good price means that it's a price that allows you to make a profit while at the same time making sure that there is demand. Of course, if you have a very, very small room that you're renting, you cannot charge too much. And at the same time, if you have a large home that you want to rent, you don't want to charge too little, because then you would not be earning as much income. And now, and D is also an example of machine learning. Notice that D does not explicitly reference building a model, but there are many parts to a mortgage application, and therefore many factors that have to be taken into account, which is essentially like building a model. Determining the customers for which the loans would be applicable for, and those that would be actually denied is actually almost like a model, okay? And these methods used to be used in a very, let's say, less scientific way. And there are many instances where machine learning can actually provide improvements in prediction. So machine learning is and can be at times part of proper data science. Data science is a process, while machine learning is a tool that can be useful in the data science process. That is, if we want to test a particular hypothesis and we want to process a large amount of data, we might use machine learning methods to achieve that goal. Okay, so machine learning is a tool that is used by a data scientist. Valentina is asking a very interesting question. What is the difference between a data scientist, a data engineer, and a data analyst? So a data analyst is a person that analyzes data using known instruments. For instance, you receive a data set and you decide to apply a linear regression. It's a method that you learn in school. In that sense, you are a data analyst. You are performing analysis using data. A data scientist is someone that uses scientific method to test new theories, to test new hypotheses. So a statistician is a data scientist, in other words, okay? So when you're trying to generate new knowledge, then you are a data scientist. Data engineer is somebody that actually works with the structure of data, how the data is organized, how the data is stored, and so on. So that's the difference between the three categories. I hope that I made sense. The last important concept that we want to define today is artificial intelligence, also called AI. This expression started over 70 years ago, over 60 years ago, in mid-50s. And it became popular again when the computing power has been developed enough to actually think about artificial intelligence. In the beginning, the concept of artificial intelligence was almost related to science fiction, okay? And the question was, can we build robots that can think like human beings? And when computers become very advanced and not simply calculators, but able to process more complex form of information, the question became actually again, okay? So what is artificial intelligence? There can be defined in different ways, but one way to define it is the ability to allow computers to understand data. So intelligence is connected to the concept of understanding and learning from the data and make decisions based on patterns that are hidden in the data. So notice that this is more than just machine learning. Machine learning is like using data without a direct supervision, without direct coding, and being able to produce predictions and output. However, when we talk about artificial intelligence, we also are requiring understanding and ability to make decisions. The whole idea is to imitate the way that human brains work and the way that we make decisions. Artificial intelligence is a technology with which we can create intelligent systems that can simulate human intelligence. For instance, self-driving cars. Self-driving cars use machine learning methods, but then they implement these methods in such a way that allow the machine to make a decision. As I was mentioning, the car slowing down when you get too close to another car. Digital assistants like Siri, Alexa, and others, or robots. And here we have a video that we can start looking at. It's a fairly long video, but we're going to check just the first few minutes. How far is the age of AI?
Tons of YouTube original stages, once home to Howard Hughes's
Can you hear
first
it now?
Goose assembly hangar, and home to much of the first Iron Man, filmed 12 years ago.
Pardon, I had
Many happy memories here. And speaking of taking a look back, technology. It's advancing faster and taking less time to be widely adopted than ever before. Like, as in it took roughly 10,000 years to go from writing to printing press, but only about 500 more to get to email. Now it seems we're at the dawn of a new age, the age of AI, artificial intelligence. Please define.
AI is a branch of computer science dealing with the simulation of intelligent behavior in computers.
Yeah, okay, there you have it. What does it mean? I don't know. Tons of folks are working on it, right? Most people don't know that much about it, and of course, there's no shortage of data or opinions. Anyway, I've heard it said that the best way to learn about a subject is to teach it. But to level with you, I have a wildly incomplete education. Not in my day job, where I've been AI adjacent for over a decade. Anyway, I figured now would be as good a time as any to catch up on the state of things regarding this emerging phenomenon. My sense of it is it kind of feels like Pandora's box, maybe-ish. Much of my understanding on this topic has come from sci-fi stories, which usually depict us heading towards Shangri-La or dystopia. Like most things, I suspect the truth is probably somewhere in the middle. Now, along the way, we'll demystify some common misconceptions about things we thought we understood, but probably don't. Terms such as machine learning, algorithms, computer vision, and big data, they will be conveniently unpacked to help us feel like we know what we're doing. Kinda. By the way, Pandora's box. What in the box? It was a clay jar. How about that? Demystified.
AI is teaching the machine, and the machine becoming smart.
Each time we create a more powerful technology, we create a bigger lever for changing the world.
Autonomous driving started.
It's an extraordinary time, one of unprecedented change and possibility. To help us understand what's happening, this series will look at innovators pushing the boundaries of AI and how their groundbreaking work is profoundly impacting our lives and the world around us. In this episode, we'll meet two different visionaries exploring identity, creativity, and collaboration between humans and machines.
Intelligence used to be the province of only humans, but it no longer is. We don't program the machines, they learn by themselves.
That's good. Right. My background's always been a mixture of art and science.
I ended up doing a PhD in bioengineering. Then I ended up in the film industry,
Working on King Kong to Avatar, simulating faces. I'd got to a point in my career where I'd been, lucky enough to win a couple of Academy Awards. So I thought, okay, what happens if we actually tried to bring those characters to life that actually you could interact with? Baby, ooh. What can you see? So Baby X is a lifelike simulation of a toddler. Hey, are you excited to be here? She's actually seeing me through the web camera. She's listening through the microphone.
We're going to stop here the video, but it gives you an idea about this interesting series if you want to learn more about artificial intelligence and the different types of applications. And I mean, it's important to get inspired to find out what type of jobs also you would like to pursue in the future. I know that we have a lot of young students connected today, and it's really, really a lot of new areas to explore, and being familiar with data science will really be important. So Felix is asking me, do you agree with statement, we are still decades away from a general AI, but really close to an interconnected machine learning world? Yes, I am substantially in agreement in the sense that to have a real artificial intelligence that is able to self-learn, to self-replicate, and so on, we are very far away. But machine learning has really taken over already almost everything. And so we are not there yet that machines can think autonomously and make decisions. And the process can actually be rather scary because any type of exponential advancement in the areas of artificial intelligence will need to be mitigated with ethical considerations and with careful use of science. So we have to remember that all of these things should be used for the greater good and not, left alone without control. Can AI be interpreted as a computer coding itself? A computer coding itself would be a part of artificial intelligence in the sense that as human beings, our intelligence allows us to do much more than just coding computers. So artificial intelligence would include self-coding, but it would be actually much more, okay? So what are the key differences between machine learning and artificial intelligence? We notice that people sometimes use them interchangeably, but artificial intelligence is a wider, broader concept. And it involves the creation of intelligent machines that can simulate the way that we think and the way that we behave. While machine learning is an application or is a subset of artificial intelligence that allows machine to learn from data without being programmed explicitly. Notice that there is not relation to understanding or making decisions, which are features that are typical of an intelligence. Okay? So artificial intelligence is a technology which enables a machine to simulate human behavior and human thinking. Machine learning is a subset of artificial intelligence which allows a machine to automatically learn from past data without programming explicitly. The goal of AI is to make a smart computer system like humans to solve complex problems. This would be the greater advantage between artificial intelligence and human intelligence, is that an artificial intelligence will have considerably large processing power. The information they will be able to process and store and interpret will be incommensurably larger. The goal of machine learning is instead to allow machines to learn from data so that they can give an accurate output. In AI, we make intelligent systems to perform many tasks like a human. In machine learning, we teach machines with data to perform a particular task and give an accurate result. So, discuss the difference between machine learning and AI with your classmates or team. You are already doing that very well in the chat. I'm seeing a lot of comments. And William is asking a very thought-provoking question. Is like humans really well-defined to be able to know how close is an AI? Is really a human the ideal goal? Well, it's not exactly to replicate a human, but the way that humans process information and understand information. So an artificial intelligence can be more intelligent than human beings, might have stronger ethical parameters, for instance, that are less conditioned by human pulsions and desires. So when we say that to think like humans, we probably are referring more to the process rather than to actually replicate a human being in all of their features. What would count as artificial intelligence? What demonstrations of aptitude would, beyond the shadow of a doubt, convince you that something is as intelligent as humans are? You might have found that it's quite hard to come up with answers. And the most ideas you had either seemed like they could well have a dumb mechanical solution, as the previous discussion, or that actually you question how unique human intelligence really is. And in fact, that's exactly the type of questions that you were defining, and whether virtually all of what we could do to be reduced to such dumb mechanical methods. So, is there any sensible test that we could determine to use if something is as intelligent as a human? There are many examples. The most famous one is the Turing test that was Alan Turing, the famous World War II scientist and cryptographer. And it's a test where a human evaluator and two conversation partners, one machine and one human. The evaluator would conduct a conversation with each through a text-only channel. If the evaluator cannot reliably tell the machine from the human, the machine is said to have passed the test. Turing did not explicitly say what can be used as a measure for artificial intelligence or intelligence in general, but many people that came after Turing proposed several approaches. The implication is that if a computer can converse like a human, then they are effectively as intelligent as humans. you can try to talk to Siri as much as you want, and Siri would respond in similar ways as humans sometimes, and then sometimes it would give you completely different type of answers. And that would really lead you to the fact that Siri is not as intelligent as humans. So I would suggest as activity for after the class to find a partner and define what are some of the things that machine can already do better than we can, and why they can do things better than we can, these things. And what are things that we can do better than machines? And do you think that this will be an advantage that we will have for still a long time? Robert says, well, detecting sarcasm is something that machines don't do well yet. I completely agree. Well, play Go, play chess. This is something that machines do better. Why is that? Well, because they have incredible power calculation. However, if you would say, well, can I create a machine that can play basketball better than a human being? No, forget it. We are not there yet, right? So in today's class, into the introductory lecture, we have scraped the surface about some of the basic concepts of what data science, machine learning, and artificial intelligence are. And you already have, with these concepts, you already have a more educated type of insight about what these words mean. And we learned that artificial intelligence is actually a complex type of statement and somewhat ambiguous. Is not completely clear yet what it means to be an intelligence, what standards should it have, should be just compared to humans, but humans are so different. So which human intelligence we would be mimicking? For this reason, I believe that artificial intelligence is more based on mimicking the process that an intelligence works, but the power and the decision making might be actually very different. In this course, we will focus mostly on data science and the applications of data science that involve machine learning, but not so much artificial intelligence. As we have said, data science and machine learning can be seen as part of something that artificial intelligence should be able to process. Because if as humans we are able to understand data science and machine learning, artificial intelligence should deal with these concepts as well. However, the focus of this course will be mostly on data science and machine learning. So in the upcoming weeks and months, you will be trained on many techniques that are used by professionals in several different areas. You will see a lot of applications, but I always encourage you to try to generalize the methods that you are using and try to think and envision other areas for which you can apply them. After all, the best form of learning is learning that you can reproduce, that you acquire, and that you can apply to different settings. So it does not just become technical knowledge, but it's much more than that. It's knowledge that is general, that is sound, and it can be a good investment for your future. And I am running out of time, and I would love to keep talking with you, and we will have many more chances, but I really thank you for your attention, for staying up so late. And I look forward to see you soon. I think that next time is going to be on Thursday. So thank you again.